So this video is over the test 5 review. First question, number 1, says determine the area of the shaded region. So that's like our yellow area here. So we're going to find the area of this section right here. And then we're going to subtract from it the white section right here, guys. Okay, so what we need to do is find the area of the yellow section. So to do that, we're going to multiply x plus 15 times 3x plus 2, because that's how we find area, right? Area is equal to length times width, okay? And we'll just say this is our length and this is our width, okay? So to do that, we're going to use the box method. So I'm going to do x and 15 up here, and I'm going to do 3x and 2 over here. I'm going to create a box here. Hopefully you guys remember how to do this, okay? So we're going to multiply the 3x right here times the x. That's going to give us 3x squared. We're going to multiply the 3x times the 15. That's going to give us 45x. Then we're going to multiply our x times our 2. That's going to give us our 2x. And then we're going to multiply our 15 times our 2, and that's going to give us our 30, okay? Now, hopefully you remember that in the diagonal right here, we're always going to have our like terms. So we're going to combine those, okay? So we're going to do 3x squared plus 2 plus 45 is 47x, and then plus 30. Okay, now we need to find the blue rectangle. Okay, so to find that area, we're going to multiply the 2x times the x plus 1. Okay, so I'm going to do that right here. 2x times x plus 1. 2x times x is 2x squared, right? And 2x times 1 is 2x. Now, we're going to subtract that from the 3x squared plus 4x plus 30. Okay, so that means we're going to subtract the 2x squared, and we're going to subtract the 2x. And this is probably the most common error right there, guys. So when we do that, if we subtract 2x squared from 3x squared, we get x squared. And if we subtract 2x from 47x, we get 45x, right? And then we are doing nothing with the 30, so we just bring it down. Okay? So there's your answer right there, okay? Now, the next one says, given the rectangular figure below, find the perimeter. So what does perimeter mean? It means the distance around the outside of an object, right? So if it's asking us for A, then we're wanting this side and that side, which would be the same, right? And then we need this one up here and that one down there. We don't have that right now. So I want you guys to notice that this whole length right here is the x plus 12. And then this partial length right there is the 2x plus 3. So to find the width of A, we're going to have to subtract the 2x and the 3 from the 8x plus 12, right? So again, remember you're subtracting both those terms. So this is going to give you 6x plus 9. So that's what this up here is going to be, 6x plus 9. So notice that we have two sides that are equal, right? So we're going to do 2 times this side, and I'm going to go 2 times this side, and that's how I'm going to get my answer, okay? So we're going to go 2 times our 4x plus 2 plus 2 times our 6x plus 9. Now, if you don't like that, then you can just put the 6x plus 9 down here, and you can put the 4x plus 2 over there, and you can just add all your like terms. 4x plus 6x plus 4x plus 6x, right? 2 plus 9 plus 2 plus 9, okay? I'm going to do it by multiplying 2 times the length and 2 times the width, okay? So this is going to be 8x plus 4 plus 2 times 6x is 12x, 2 times 9 is 18. Then we are combining like terms, right? Our 8x and our 12x would give us 20x. And then we're going to add our 4 and our 18, and that's going to be 22. So that would be our answer there, okay? So the next one says, for questions 1 through 5, identify the transformation. So to find this, we're going to connect our vertices, A to A prime, B to B prime, and C to C prime, okay? So do you notice they cross? So what we learned when we taught this was if they cross, then this has got to be a rotation, right? Now, how many quadrants did we move? We moved 1 to the left, right? So that's going to be a 90-degree rotation, or what? A 270-degree clockwise rotation, okay? So here again, we're going to connect A to A prime, B to B prime, C to C prime. Notice those lines are parallel and the same length, which means congruent, right? So that means this is a translation. Okay, now let's count how much. Let's go left, right first. So I'm gonna go from A here to 1, 2, 3. So that's 3 left. And then I'm going to go down how far? 1, 2, 3, 4. I think something moved, y'all. So that's 4 down. And I want to talk to y'all what that vector would be too, because you know it might show up as a vector like on the final. So what vector would this be? -3, -4, because we're also trying to review for the final here, okay? All right, so our next one, that was translation, 3 left and 4 down. So A to A prime. And then we got B to B prime right there. And then we got C to C prime. Y'all notice that? So those lines are all parallel, but they are not the same length, are they? So this is going to be a reflection. Remember, if the lines are parallel but not the same length, it's a reflection. So, and we're going to bisect those lines to find our line of reflection, okay? So this is going to be a reflection over the x-axis. Okay. Okay, so the next one, again, going to connect our vertices, F to F prime, and then I'm going to go E to E prime. Whoop, they crossed. Okay, so I know right now that it's a rotation. And how many quadrants did we move? So we moved 1 there, so that's our 90 degrees, right? Moved another one down to here, so that's another 90, so that's 180 degrees, isn't it? So this is a 180 degree rotation. Remember, every quadrant is 90 degrees. Okay, so this next one is a dilation, and I understand that on y'all's notes it's a little hard to see, but I think you can tell that if we go from F to F prime, we go from the green shape to the purple shape, it got smaller, right? So it's going to be a dilation. Now we need to find our scale factor. Dilation by a scale factor of, let's see if we can find that. So let's just look at one point. So let's look at F. F was -8, 2, and let's look at F prime. That one is -4, 1. Okay, so this is how you find your dilation factor. You take your dilated point over your original point. So your image over your pre-image, okay? So we're going to actually just do the x, and then we're going to do the y. -8, sorry, no, -4. That's the F prime. -4 over -8. And isn't that equal to 1 over 2, y'all? So we had a dilation by a scale factor of 1/2, didn't we? We did. All right, so this next one says, what are the coordinates of triangle RST with the points R, S, and T when rotated 270 degrees clockwise after reflecting the image over the x-axis? I scratched out the y equals because it shouldn't have been there. Okay, so do you guys notice this key word right here, after? So that means that we did the x-axis first, and then we rotated it 90 degrees. So you guys need to be watching for that, because that's something that we've commonly seen on finals in the past. So we're going to do this first. We're going to reflect over the x-axis, so that's x, and change the sign of y, right? Let's go ahead and talk about what this other rule is for a 90 degree clockwise, or 270 degree clockwise rotation. Isn't that the same as a 90 degree rotation? It is. And if you guys remember, that's -y, x. That's the rule. You guys got to know these rules, okay? So what we're going to do is we're going to go ahead and do R prime, S prime, and T prime. So on these, aren't we just changing the sign of the y? Exactly. So this is going to be -2, +6. This is going to be 1, +3. This is going to be -2, -5, okay? Now, when we do our rotation, R double prime, S double prime, and T double prime, we're going to flip them. Notice they're flipped, and then we're going to change the sign of y. So this time we're going to take our R prime, we're going to flip it, and we're going to go -6, -2, right? We're going to go -3, 1, and we're going to go +5, change that sign, -2. So those are your transform points after doing the reflection over the x first, and then the 90 degree rotation or 270 degree clockwise rotation. Okay, so in this next one, number 5, it says there are 3 triangles in the image below. Are there a pair that are congruent? So I'm going to draw these in 2 different colors so you guys can clearly see them. So I'm going to draw this one in blue. And then I'm going to draw the other one in red, okay? So I got this side, and then that side, and then this top side, okay? So I clearly see that we do have 2 triangles that are congruent, so the answer is yes. Now we're going to talk about why. So if so, write a triangle congruent statement. So I'm going to talk about my blue triangle first, and I'm just going to name it HJN. And what is that triangle congruent with? Okay, everybody listen and look. So notice I did H, which was 2 arcs, and then J, nothing, and then 1. So we're going to do the same thing in the red one, okay? So this one's going to be triangle, 2 arcs. That was G, right? H has 2 arcs, G has 2 arcs. J has nothing. What has nothing in the red one? K, right? And then what has 1 arc? L, okay. So now when we talk about why the triangles are congruent, we're going to go around one of the triangles. So I'm going to go around our HJN. So I got an angle right there, I got an angle right there, and then I have a side. So that's why the triangles are congruent. Angle, angle, side. Okay? For number 6, it says what additional statement, congruent statement is required or must be there to prove HL. So first of all, HL has to do with what kind of triangles? Right triangles, right? So notice we have this side and that side that are congruent. Those are legs, yes? Where is the hypotenuse in a right triangle? Opposite the right angle, right? So we're going to talk, I'm going to say BC. So I went from the 1 tick side across there. So that's going to be congruent with what? If I go from the 1 tick side across there, isn't that going to be CB? You guys got it, okay? And remember, we don't have to write this here, but that's the symmetric property, right? Because they flipped, okay? Now, let's talk about the other one. It says, what additional congruent statement must be made to prove side angle side? So we had our side here, right? And then we have an angle, so don't we need that side up there? And again, we got our side and our angle, so we need that side down there, right? So that's going to be, okay, let's talk about this again. I'm going to go from right to nothing. So I'm going to say AC. So here I'm going from right to nothing. Y'all see that? So that's going to be DB. Now look, you got to write these statements correct, and you got to find the right statements when you guys are looking for these on the test, okay? All right, so this next one says, put the following images in order to construct a perpendicular to a line through an external point. Perpendicular to a line, we're going to construct the line perpendicular to the line through a point, okay? So our first step would be just that point, right? Okay, and our last step would be that line drawn. So what do you think would be the second step? Yep, right there, because it's got the 2 arcs. You're looking for more and more, okay? So you're going from hardly anything on the drawing to a lot on the drawing. So there's some logic to this, guys. So look at the drawings, okay? So this next one says, put the following images in order to bisect an angle. So we got to have an angle first, right? And then we have, again, this last step right here, 5, because that's where the angle's bisected, right? So now let's look at what we have next. So don't we have to draw 2 arcs across the angle? That's step 2 right there, over there on the right. And then what would be step 3? Creating arcs from where we created the original 2 arcs, right? So that would be step 3 right there. Then we drew the intersection of those 2 arcs, that's 4. And obviously our last step was step 5, where the angles actually bisected. All right, so this next one says, use the slope formula, distance formula, and properties of special quadrilaterals to prove whether this triangle is a parallelogram, a rectangle, rhombus, or a square. Okay, so this is what we're going to do. We're going to start with AB, and we're going to find the slope. So we're going to count up and over, right? 1, 2, 3, 4, 5, 6, 7, 8 up, and 1, 2, 3, 4 over. So that is reduced to be what? 8 divided by 4 is 2, right? Okay, so now we're going to use that rise and that run, those original 2 numbers, to find our length. Okay, so to do that, we're going to do, if you remember, we're going to do 8 squared plus 4 squared. So that's what? 64 plus 16. And that's going to be 80, right, y'all? So that's equal to the square root of 80. Now, sometimes we're going to ask you the answer to this question, and you're going to have to put this in simplest radical form. Okay, so most of y'all can see that 80 is divisible by 4, right? And 4 times what? 20. We still have a 4 as a factor of the 20, though, don't we? So we got another 2 there, and 2 times 5, sorry, 4 times 5, my bad. 4 times 5 is what? 20. Okay, so what we're going to do is we're going to take these two numbers here because they're the same. 4 times 4 is 16, right? So we're going to do the square root of 16, and then we're left with that 5. Y'all see that? Square root of 5. So y'all, what is the square root of 16? Just reminding y'all how to do this because it's been a minute, okay? So that's going to be 4, right? And 4 square root of 5, okay? So that's the length of AB. So now let's talk about the slope of BC. So BC, we're going to go up 1, 2, 3, 4. Again, up 4. And over 1, 2, 3, 4, 5, 6, 7, 8. So that's now 4 over 8, which is 1/2, isn't it? Okay, so those are the same two numbers we had before, right? A 4 and an 8. So we know that this is also going to be 4 square root of 5, right? Because they were the same numbers. All right, let's look at CD. So CD, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4. So again, 8 over 4, that's our 2. Again, same two numbers, so this is going to be our 4 square root of 5 again. All right, got one more side to do, right? So we're going to do AD. So I'm going to go, if I go from A to D, I'm going down 1, 2, 3, 4, right? And over 1, 2, 3, 4, 5, 6, 7, 8. So that would be what? -4 over -8, which is, again, a negative divided by a negative is a positive, right? So that's 1/2. So those, again, no matter whether we square a negative or a positive, we get the same number. So this is still 4 square root of 5, right? Okay, we're going to talk about what all that means in just a second. Okay, now we're going to talk about the slope of CA and the length of CA. Okay, so we're going to do this in a different color. Let's find orange. How about that? Okay, orangish. Okay, so we're going to talk about CA. So that's this right here, right, y'all? So we're going to, again, go, that falls from left to right. So that's 1, 2, 3, 4, -4 over 1, 2, 3, 4 over 4. So isn't that -1? Okay, now again, remember, we're going to square those. So negative times a negative is a positive. So that's going to be the square root of 16 plus 16, right? That's going to be the square root of 32. And isn't that the same as 2 times 16, y'all? So that's going to be the square root of 16 times the square root of 2. So that's going to be, what's the square root of 16? 4 square root of 2. Okay, so if we simplify that as far as it goes, now let's talk about BD. This is the other diagonal, right? So again, we're going to talk about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that was 12 up, and there's -4, and that goes to, is that right, y'all? -7. No, what is that? -6. So this is -6 over here, and that goes to 6. Teaching y'all a little hack here, okay? Right? So that's going to be 12 as well, isn't it? Okay, and that's rising, so that's going to be our 1. All right, then what are we doing? We're doing, again, the square root of 12 squared, which is 144, plus 12 squared, which is 144. So wouldn't that, again, be the 2 times 144? Y'all got me? So that's equal to, I'm just going to go the square root of 2 times the square root of 144. What's the square root of 144, y'all? 12, right? So this is going to be 12 square root of 2 if we simplify that side. Okay, so now let's talk about what we have found to be true. I'm going to move this down so we have a little more space to work with. Okay, so what have we found to be true? So we have, notice all these sides are the same, right? So we can say, let's just do this in black. So we can say that AB is equal to BC is equal to CD is equal to AD, right? So that means it's either a rectangle or square, I mean a rhombus or a square, right? Then we notice that the slopes are not perpendicular, right? They're all positive. Do y'all notice that? So we can't say anything about the relationship of the slopes except for opposite sides, or the opposite sides of this shape. The slopes are parallel, right? So that means this would be parallel with that, and this would be parallel with that. Yes? Okay, we could say that. But then what about the diagonals? What do you guys notice about the diagonals? The slope of this one, you know what I did not put up here? Nobody noticed that. -1. That's a -1 in 1, right? So what could we say about CA and BD? CA is perpendicular to BD. And isn't that a property of... But what do you notice about the lengths? The lengths are not the same of the diagonals, right? So it can't be a square, because if it was a square, then the lengths would be the same. If it was a square, the slopes would be perpendicular, right? Okay, so this is a what? A rhombus. Because all four sides are congruent and the diagonals are perpendicular. Okay? All right, so this next one says identify the following triangles if the following triangles are similar or not. Okay, so what we're going to do is we're going to go ahead and I'm going to mark these vertical angles, because that would be true, right? Those angles would be congruent. And then also let's go short side, 1 dot to 1 dot, and then let's go longer side, 2 dots, 2 dots, okay? So it looks to me like maybe we could have side angle side similarity here, okay? But what we need to do is we need to determine if these sides produce the same ratio. So we're going to go 9/15. When you do 9/15, what does that reduce to be? So that reduces to be 3/5, or if you don't like to reduce fractions, 0.6, right? Now we need to make sure the other one is the same, right? So we're going to do the other one as well. So we're going to do 18/30, and if we want to reduce that one, guess what? That one also reduces to be 3/5, or 0.6 again. And so, yes, we can say, it says identify if the triangles are similar or not. The answer is yes. If they are similar, identify which postulate proves the triangles are similar. So this would be side, angle, side. And I'm also going to write the triangle similarity statement, okay? So I'm going to say triangle ABC is similar with, okay, so I started at the end of the long side, right? So what am I starting with over there on the right? The end of the long side, right? So that would be D. And then I went to across the nothing side, right? Nothing's on that side, so I went D, E, and then I ended at the vertical angle, right? So that's what I'm going to do there, okay? So now on letter B, it says again, identify if they're similar or not, okay? So again, we have our vertical angles, don't we? And we have this other angle that's 39 here, and it's 39 there. So are these triangles similar? Again, the answer is yes, because of angle, angle, right? If two angles are congruent, then you know that the third angle has to be, right? So all three angles really are congruent here, but we only really need to know 2. Okay, so here again, let's write a statement. So this time I'm going to say GHM. Okay, so look where I started. I started where there's nothing, and then I went to the 2 arcs, and then I went to the 1. So over here, I'm going to start where there's nothing. So that's J, and then I went to the 2 arcs, right? So that's K, and then I went to the 1. So that's where my M is. So that's my similarity statement. So remember, you got to go from congruent things or our dots. We got to use either one of those, whichever occurs, okay? So this one says line segment AB bisects DE at point C. And then it gives us the length of DC and CE with equations. This is what definition and postulate are used to solve this problem. John labeled the given information, then find, and we changed those because they were wrong. Okay, so everybody listen. It says line segment AB bisects DE. So I'm going to draw DE first. And then I'm going to bisect it with segment AB. So that means that these two segments then are congruent, right? And then it says DC was 2x plus 4. And CE, oh, I didn't put the point C right there, y'all. Point C, at point C. CE is 3x minus 1. So those two are congruent, right? So can we not set them equal to each other? 2x plus 4 is equal to 3x minus 1, right? So let's subtract the 2x from both sides. So now 2x is gone from there, and this is just x. We're going to add 1 to both sides. So x is equal to, that's now gone from there. That's 5, right? Okay. So now it's asking us to solve for these different lengths, right? So DC is going to be 2 times 5 plus 4. That's going to be 14, right? Then CE is going to be equal to 3 times 5 minus 1, which is 14. Now, do you notice that they're the same length? They should be the same length, right? Because doesn't it in the drawing show us that they're congruent? Indeed. Then we can do DE, which is equal to 14 plus 14. So that's equal to 28. Now it asks us what definition and postulate are used to solve this problem. So the definition was bisects, right? And what is this postulate that we use? The segment addition postulate. Y'all got me? So that's the postulate. Segment addition postulate. Okay, so for number 11, it says find x, the angle L, angle M, L and M, and O and M. Okay, so here's the thing you have to notice with this drawing. Y'all got me? That this right there creates an exterior angle. Okay, and when we have an exterior angle, then it is equal to, so basically this angle out here, guys, this red angle out here, is equal to when we add together these two blue angles right here. So these are called remote interior angles, y'all. So when we add these two angles together, L and M, we get angle O and M. So I'm going to say angle L plus angle M is equal to that exterior angle, which is O and M. Okay? So that's exactly what we're going to do. We're going to do 4x plus 2 plus 2x minus 9, and we're going to set that equal to our 5x plus 13. Combine our like terms right here. So that's going to be 6x, and 2 minus 9 is minus 7. That's equal to 5x plus 13. Now we're going to move our x's to one side and our constants to the other. So I'm going to subtract 5x from both sides. That's going to leave me x over here, and that's now gone. And we're going to add 7 to both sides. So that means x is equal to 20, right? Okay, so now it wants us to also put those back in, right? So we're going to find each angle measure. So angle L is going to be equal to 4 times 20, that's 80, plus 2, so that's 82 degrees, right? Then we have angle M, which is equal to 2 times 20, that's 40, minus 9, so that's equal to 31 degrees. Okay, notice now that we have two angles, so we have 82 here, and we have 31 there, right? So now we could use the angle sum theorem, right, to solve for that angle right here, which that angle is LNM. So angle LNM is going to be equal to 180 minus the 82 plus the 31, right? So that is equal to 113. No, 67. Sorry, my bad. 67. Wow. Okay. So now, I don't know what that's up about. So then we have one more angle to solve for, right? That question mark angle right there. Okay. So when I solve for, that was the L and M. And we have, we have the exterior angle to solve for, right? So that's our angle O and M. So here again, we can do what? We can do 5 times 20, that's 100, plus 13, and that equals 113, right? Now notice, hopefully you guys noticed this, these two angles, when we add them together, they equal 180. Why is that? Because they form a line right here. Y'all see these two angles right there? They form a line. Got it? Good job. All right, so this is complete the following proof given the word bank. So we're given that AC, it says here, is parallel to BD, right? So I'm going to mark that. Then the next step here I would do, and what we did before was we are going to look at some alternate interior angles. Okay, so I'm going to redraw these lines a little cleaner so you guys can see them. And then I have that transversal right there. So can't we say that the measure of angle 1 is congruent or equal to the measure of angle 4? Why is that? Why are these angles congruent, y'all? Because they're alternate interior angles, right? So it's alternate interior angles theorem. Okay, then we have another pair of alternate interior angles, don't we, guys? Okay, so let's see where this one is. We have another line right there, don't we? So isn't this angle right there congruent to that one? Can't see what that number is, 5. So 5 is congruent to 3. So notice, okay, so we use that one right there. And we use alternate interior angles theorem. So now we're going to use this one, right? So the measure of angle 3 is equal to the measure of angle 5. Okay, so we're going to scratch through that one. That one's done. Then what would be the next logical statement? Okay, so do you guys notice this right here? That's another mathematical statement, is it? That's everything that's on the left are mathematical statements. So the measure of angle 2 plus the measure of angle, wait, just do it the way it's written. The measure of angle 1 plus the measure of angle 1 plus the measure of angle 2. Sorry, I am having problems, y'all. I skipped down to the prove. Measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 equals 180. So everybody look up here. It's talking about 4, 2, and 5. Don't they form a line right there? So what would be the reason for that statement? Angles of a straight angle, right? So angles, straight angle is a straight line, right? Of a straight angle. Okay, so what's the only thing that's left, guys? Substitution, right? So what was substituted? Let's see if we can figure this out. So if we look at angle 1 here, what is 1 equal to? Angle 4, right, y'all? So 1 and 4 right there. And then what do we have? The angle 2. Nothing was substituted for 2, right? So then look at 5. 5 was congruent with 3, wasn't it? So they substituted the 5 for the 3. So this is substitution. So we've done this proof multiple times, guys, so you should know it by now, okay? For sure. All right, so the next thing says, what are the image points of, it should be W, X, Y, okay? So to do this, we're going to find W, which is 3, 4, right? I'm going to go ahead and find them all right now, and then we're going to work it, okay? X is right here. This one's 4. -3, right? And then Y is -4, 3. Okay, so to find these answers, we're going to multiply 4/3 times 3, and we're going to do 4/3 times 4, okay? So when we do 4/3 times 3, for W prime, we're going to get 4. And we're going to get 5.33. Okay, so now think. We've already done 4, so we don't have to do it again. So this one for x prime is going to be what? 5.33. And didn't we already do the 3? We did. Only thing is this time it's going to be negative, right? So that's going to be a -4. Y'all see that? Okay, down here, again, we did 4, right? So that's going to be 5.33, only it's going to be -5.33, right? And we already did a 3 all the way up there at the top, so that's a 4. So that's our Y prime. So we only have to do them once because the points were the same for all of them, except sometimes positive versus negative, or they're just flipped, okay? So this next one says, given that the triangles are similar, find BC. So it tells us they're similar. So we're going to go short side to short side, middle side to middle side, long side to long side. So hopefully you guys can see the EF and BC are short side to short side, right? Then we've got 25 is my next longest length and 15. And 35, and 21. Now we use these dots just to figure out what the smallest, the middle, and the largest are so that we can orient them. Now in this particular case, we're going to go 15 over BC, because that's our 1 dot 1 dot. And then I'm just going to use our 2 dot 1. So I'm going to do the 25 over, what was 2 dots on the other side was 15, right? So this is we're going to cross multiply here, remember? Cross multiply to do these, right? So this is going to be BC, 25 BC is going to be equal to 15 times 15. So this is going to be 25 BC is equal to 225. And how many times does 25 go into 225? Going to divide both sides by 25 here. So BC is equal to 9. Now remember, you can check this, okay? So 15 over 9, is that equal to 25 over 15? Well, 15 over 9 was 1.6, so yeah, 15 over 9 was 1.67, and so was this, okay? So it's an easy way to check it. All right, so this next one says find the height of the tree. So it's asking us to find this height right here, right? The height of the tree, and that relates to this 12, right? So I'm going to say h over 12, and that's going to be equal to this whole length right there. Hear me, guys. The whole length, which is 28, right? So that's going to be equal to 28 over this part right there, the 8. Okay? So we're using the flag to find this. So then we're just cross multiplying, right? So 8h equals 12 times 28. And I got 12 times 28 was 386. So 8h equals 386. Divide both sides by 8. So h here was equal to 42 feet, right? So remember, little triangle, little side, big triangle, big side. That's what you got to really, really, really remember here, okay? Now, the difference between this one and the last one, the number 16, is we have a pair of parallel sides, right? So this is the way I taught it. So I told you all to draw that, right? And then remember, we got to find this BD right here. This right here. Don't we have to find that? So aren't we going to do 28 minus 8 to get this? 28 minus 8, that's equal to 20 right there, right? So that's the length of BD. So now I also taught y'all, I taught my kids a hack here, right? So we can create an X here to skip a step. Now you don't have to skip this step, but you can create that X right there. So that when we do that, that's going to be 4x times 20, right, is equal to 8 times the 9x plus 3. Now if you don't like that, again, you can set up your ratio. So if you set up your ratio the way it's drawn, it would be 4x over 9x plus 3, right, equals 8 over the 20. Now look at that step. Do you notice our cross multiplication right here? Boom. That's our 4x times the 20, and then here's our other side. Got it? So it doesn't matter whether you do it with the first step or not, okay? So then this is going to be 80x. 8 times 9x is going to be 72x, right? And 8 times 3 is 24. So that's going to be plus 24. So I'm going to subtract the 72x from both sides because I got to get all my x's on one side. Okay, so now that's gone from there, and this is going to be 8x equals 24. Then we're going to divide both sides by 8. So x is equal to 3. Okay, so it said find x. We did that. Now we need to find AE. So AE is going to be equal to 4 times 3. That's 12. Then we're going to find EB. So that's going to be 9 times 3. That's 27 plus 3 is 30, right? Okay, and then it's asking us for AB. So don't we just have to add those two pieces together? 12 plus 30. That equals 42. And again, you can check your answer by doing the 4x, which was the 12, over the 30, and see if that's equal to our 8 over our 20. 12 divided by 30 was 0.4. And guess what 8 divided by 20 was? Also 0.4. That's what we're looking for, okay? So here's our last problem, y'all. So it says find x, y, z, and then the perimeter of MSR. So if I'm trying to find x, I notice that I got an x right there for x, and then I got this right here. Aren't those going to be congruent, y'all? Indeed they are, because remember, these SR, this whole side is 2 times our mid-segment that's parallel to it, right? So we're going to just set these equal to each other. So we're going to say 4x equals 5x minus 3. So I'm going to subtract 5x from both sides. So that gives me a negative x equals negative 3. Now you can either multiply or divide by negative 1. I'm going to multiply by negative 1. So x is equal to 3 here. Okay, so let's plug that back in. So we can find this length right here. 4 times 3. So this length is 12, which means that length is 12, which means that length is 12. And what is 12 plus 12? 24. Okay? All right, let's find y now. Okay, notice we have y there and we have y there. And those are also congruent, aren't they? It even shows us that with the tick, which means that that also is the same length, yes? Because that's our parallel side, or our parallel mid-segment to our side. So here we're going to do 4y minus 9 equals 3y plus 4. Okay, so we're going to subtract 3y from both sides. So that's gone from there, and that's going to give us y. We're going to add 9 to both sides. So that's going to be 13. Okay, so that means this is 13 and this is 13, which means that whole length is 26, right? And this also right here is 13. Okay, we got one more side, right? A z. Okay, so let's find our z. So we've got z here, and we have this whole side is z, okay? Now, we could either multiply our mid-segment by 2 to get our whole side, or we could divide. I don't want to divide because I don't really want to divide 8.5 by 2 or 7 by 2, okay? So I'm going to multiply 2 times our mid-segment, which is 6z minus 1, and I'm going to set it equal to the whole side down there, 7z plus 8.5, okay? Let me extend this and move it down a bit, okay? So that's going to be 12z minus 2 equals 7z plus 8.5. So I'm going to subtract 7z from both sides. So that's gone from there, and this is 5z now. And I'm going to add 2 to both sides. So that's going to be equal to 10.5. Now I'm going to divide both sides by 5. So that means z is equal to 2.1. Okay, so now let's find that side. So we're going to find CT is equal to, right here, this side right here, guys. 6 times 2.1 minus 1. So that would be 12.6 minus 1, which is 11.6, right? Okay, so now we're going to plug it into the bottom too. So for MR, MR is equal to 7 times 2.1. That would be 14.7 plus 8.5. So that's going to be equal to 23.2, right? 23.2. So that's that whole side, yeah, right, y'all? So that's the whole side, 23.2. This point right here would have been 11.6, right, and 11.6, okay? So then, what is it asking us for? MSR. So it's asking us for MSR. So it's asking us for the triangle, y'all. So we're going to add together triangle MSR, the perimeter. So we're going to add the 26 plus the 24 plus the 23.2. Y'all see that? 26 plus 24 plus the 23.2. When I add those 3 together, trying to see where I wrote that, y'all. 26. Whoa, pause. Just caught an error, y'all. Okay, so this is not right because we never plugged that 13 back in there, guys. Okay, so it's a good error to find. So 4 times 13 is 52 minus 9, and that is 43, guys. So this, we didn't mark it right. It's not right. So this was 43. That was 43, and this over here was 43. See, teachers can even make errors, So that couldn't have been 26 right there. So what is 43 plus 43? Isn't that 86, guys? That's the length of that side. So that was 86 right there. Okay, so when we add all that together, we got 133.2, and that's the perimeter of the triangle. Okay? All right.